Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to show you how I will do part modeling for this vertical shaft. In the previous video, I have already shown you how I did the blades. So this is another photo of the vertical shaft. Okay, in this part modeling of the shaft, I will do some modification. Instead of we have 5 blades, I will do 6 blades. So it means that in this modeling I will do, because attached to this shaft we have arms here. So instead of 5 arms, I will do 6 arms. Later in this video I will also show you, because we have 6 arms and the orientation of the arm is kind of like they are repeated into kind of like a spiral curve going upward. So I will show you how I will do a repeated pattern by using curve driven pattern. So it means that we only have to model one arm. Also to remind you, for the first arm at the bottom here, when I extrude, because the rough shape of the arm is kind of like a block here, so when I extrude to the surface of the cylinder, I will not merge the entirety, so it means that we make the first arm as a separate body. Later I show you. Okay, this is a rough dimension of this vertical arm, and the length is 103 and the diameter is 40, and we have a square holes here cut through 25, and okay, as you can see, there will be kind of like a spiral repeated pattern going upward for this arm, and the rough sketches is the dimension for the arm. So the length of the arm is 15 and the thickness of the arm is 10. And also at the arm, they have kind of a pin here. The pin is where there will be, in this video later I will show you how I insert a screw M1.5 into, and we can create, because inside this pin there will be inner thread. So how we can subtract that pin, that screw we have external thread, and it will create an inner thread. Okay, let me start do the part modeling in Solidworks. So make sure unit is mmgs. So in the top plane I will do a circle of diameter 14. I extrude it to 103. Oops. 103. So this will be the base shape of this particular arm. Okay, if you look in this photo again, the first arm from the base here is distance is 5 and the length of the arm is 15. So in this sketch it is on the left, but in the Solidworks on the front plane, oops, let me go to normal view. Let me pan it a little bit. Okay, so what I will do, I will create first I will create a center line up until here, and then I will create a center line. I will do it to the right. The first arm is going to be to the right, and I give a distance of 15, since the length of the arm to the center of the shaft is 15, and the level from this to here is 5. Alright, the idea for me, The idea of the center line is I can create a normal plane here, so I can extrude a rectangular shape to create up until to this body. I extrude it to this body to create the base shape of the arm. Okay, I have this line, so I can create a normal plane there. Alright, so this normal plane, I will create a sketch. Okay, if you look in this dimension, the length of the arm is the thickness of the width of the arm is 10 and the thickness is 3. So I will create center rectangle at this origin point. The width is 10. Three is the thickness. Then I will extrude. Okay, this is very important. Take note on this. Direction is reverse. Do not click at merge. Uncheck merge because I want to make the arm as a separate body. So if you put at merge, I think there will be problem if you want to do repeated pattern of curve driven of the remaining 5 arms. So make it as a separate body. Uncheck the merge result, and here instead of using blind, I'm using up to body. See, up to body, then it will stop at this body. So now I have the rough shape of this arm. Alright, the next move is that I will, if you if you look in this sketch, actually I do a modification here. This must be, hold on, this must be 2 units. So at the corner here, they kind of like have a cutting here, so I will do chamfer by the distance of 2 and this thickness is 10. So at these edges, at this edge, I will do a chamfer. Okay, chamfer, I'm not using angle and distance. I will use second option, distance 1, distance 2. And make sure do not use symmetry, use asymmetric. And the distance is 2 and the distance 2 is 10. So we kind of like have an angle here. Okay, just to show you that since I've already extruded this arm to this up to surface, so I uncheck the merge result, so we have 2 separate bodies. If you see here, we have one is the shaft and this one is the arm. Okay, better I isolate the arm from the shaft so I can make a detailed modeling onto this arm. Alright, if you look in this photo, the arm at the end here, they kind of like have a curve here. So I will do fillet by radius of 2 at this edge. Okay, then if you look again on the top surface of the arm, we have a pin by the distance of 5 and the diameter of the pin is 3. So at this top surface, I will create a circle. The center point of the circle is concentric to this curve. Diameter of 3 and extrude it to 5. So we have kind of like a pin here, and also the pin is they have a dome shape here. So I will do a fillet of radius since the diameter of the pin is 3. So I will do fillet at this edge by the radius 1.5. Okay, this is a pin on top of this arm. The idea of having this pin on top of his arm is that later I show you how I insert M1.5 screw and also a blade, because the blade will be attached at the bottom surface here, and also I will attach the screw on top the plane of the blade at the bottom plane of the blade, and I will do combine subthread to make inner thread here, since screw have external thread. Then I will position the screw I insert at bottom position, because the screw will fasten the blade to this pin here, to this basically to this arm. And this pin, since the screw will be passed through here, we have inner thread inside this pin. Okay, later I show you how I will do this. Alright, the next move, at the bottom plane of this arm, if you look in the photo here, this is the bottom view. They have this is the location of the pin, but here we have an extruded cylinder here by the diameter of 2. Actually, there will be a small pin here, so I will create a curve at the bottom surface here, and okay, I create a sketch at this plane. Okay, another thing to mention, that when I extrude the top pin just now, I must on the sketch, so I can use this curve as my reference. So what I will do, I create a center line from the center point to somewhere around here, and I will make the center line and hold down my control key and select this edge, make it parallel, and the distance, not the vertical distance, the angular distance, the aligned distance is 6. Okay, then I will do circle at this point of any radius. Then I exit the sketch. Then I go to standard view. The idea of me creating this circle is for me to, because I will insert part, I will insert the blades modeling that I have done. So this is my blade. So then this blade, I will position it, features, move, I select the blade. Okay, the top surface of the blade, sorry, not the top surface, the bottom surface of the blade must coincide with the bottom surface of this arm. So next mate setting is the cylindrical surface of this blade must match with this circle that I have just created. So I click add, and the last thing is that this cylindrical surface of this blade must match this cylindrical surface of the pin. Then I click add. So if I click OK, my blade is in position. Okay, what I will do, I will do subtract under insert features, then I will do combine, then mesh to use subtract. The main body will be this arm, bodies to combine is the blade. It means that the blade will be cut out. So we have, if I click OK, I have this form of my arm. So since okay, this, I will cut out this thing. I need to remove this portion. So at this sketch plane, okay, let me drag a little bit like this. At this sketch plane, I select this edge, convert that to entities, then I will do extrude cut, reverse direction to all. So I need this surface to remain as a plane surface. And one thing that I found out that this shaft here, this shaft is meant for the blade have. If you look, if I open the blade file, okay, the blade file we have two holes here. One hole here will be mounted to the, will fit at this small pin here, and the other hole of the blade will be here. So I found out that since the hole looks so big, so it means that I have to reduce my original blade file. I reduce the diameter to 2, make it a little bit smaller, then I save the blade file. Then in my this part modeling, if I click update, automatically the shaft here will be reduced. Alright, now I have the basic form of my arm. Okay, since there will be inner thread inside this pin and also here, what I will do, I will insert the blade again to put the blade here, click yes, then I will move the blade, okay, the blade to move, okay, but now the top position, sorry, okay, the body to move is the blade under the mid setting. This top surface of the blade must mesh with this bottom surface. I click add, and this cylindrical surface must mesh with this pin. I click add, and this cylindrical surface must mesh with this pin, and I click add. And now I position again my blade. Alright, then I will insert the screw to position the screw into the right position. So I will insert part. Okay, I already done this modeling of this M1.5 screw here. So this screw, I will move it. Features, move, body to move is this screw, and the mate setting, this flat surface of around. Okay, body to move is the screw. Okay, under the mate setting, I select the bottom surface of this screw head and must mesh with this bottom surface, but I click under here the mate alignment, I click anti-align. It means it goes to the other direction. Then I click add, and also the cylindrical surface, of the screw must mesh with this cylindrical surface of these holes of the blade. And I click add, so my screw is in position. Okay, when my screw is in position and my blade is also in position, what I will do, subtract. Screw will be subtracted to this arm. So the point of me doing this is I will have inner thread inside this pin. Okay, please take note on this. So what I will do, I will use features, combine, use subtract. The main body will be this arm. Bodies to subtract is the screw. I don't have to select the blade because I already have the cutout. I've already done in my previous step. So I only select the screw to be cut out. So bodies to combine is screw, then you subtract, then I click OK. Then I will then delete body. I will delete the blade. So hold on. Make sure I am not selecting. Okay, use delete body. I will delete the blade. Click OK. Then we have the inner thread inside this arm. If I click as a session view, as you can see, we have the inner thread. Alright, I hope you understand the way I'm trying to explain to you how we do this inner thread. Alright, the next move is that if I exit the isolate, okay, since if I go to standard view, alright, we have two solid bodies here. One is the main shaft and the other body is the arm. Alright, that's the idea of me creating this arm as a separate body. So my next move, if you look in this photo, this arm is repeated upward, kind like a spiral curve, spiral movement. If you look, this our base arm is here, and then is our second arm here, and then the third arm is somewhere at the back there. And also I need to create total arm will be 6, and I mentioned that I need to make it 6 blades. So it means that if you look from the first arm to the second arm and the third arm, the division of angle is kind of like 120 degree. So then it's repeated again, arm number 4, 5 and 6, so 120 degree, 120 degree. So, and I need to add another 5 more arms above, and if you look the pattern that repeated kind like a spiral shape. That's why in Solidworks it means that I don't have to build this arm again and again and again. In Solidworks they have curve driven pattern. So what I will do, I will create a spiral here, spiral curve, and the arm that I have just created will be repeated pattern along the spiral curve, and I give the number is, I add another 5, so at total I have 6 arms. Okay, what I will do, okay, to draw the spiral curve, before I make curve driven pattern, it means I must create the spiral curve. Okay, to do the spiral curve, okay, at this bottom plane, I have to add one plane above 5 millimeter from the bottom. So this will be my first reference, then 5 millimeter is the distance that I click it. Okay, at this plane, to draw the spiral, we must have a base curve, which is the circle. So at this plane, I will create a sketch. Let me go for proper view. Okay, I'm now in sketch mode. Okay, and in this sketch mode, I will select the circular edge of the column. I convert that to entirety, so it means I have a trace curve here, trace circle here. Then this circle can be used as a base for me to create the spiral. So make sure do not exit the sketch. If you look here, if you have a circle, then you can create spiral curve. Under features here, under the curve here, we have helix and spiral. Okay, if you look the setting of this helix and spiral here, on the left here, we have option to use pitch and revolution. Pitch and revolution, I mean this distance from the peak, and the peak is the pitch, but I'm not using pitch and revolution. I use the basic one, height and revolution, because I have already calculated the start of my spiral is here, and it goes up, the distance is 65 millimeter, so the height will be 65 millimeter. And also do not use variable pitch, I use constant pitch. Okay, the reverse direction, if I click, I uncheck reverse direction, it means our spiral will going downward instead of upward. Then I click reverse direction. Okay, and the height is already 65, and the revolution, why do I put 1.667 revolution? Okay, please take note on this. This depends on, okay, since I already have this my base arm, and this base arm need to be duplicated in terms of spiral pattern, and I need to add another 5 more above. Okay, since as I told you in this picture, the division of the angle from the first arm to the next second arm, since it's kind of like divide by 3, so full circle is 360 degree. The division of angle from the first arm to the second arm is 120 degree. But I already done the first arm, but another 5 arms above, so I need to add 120 degree, 120 degree, 120 degree, and another 5. So it means, if you look here, this is the calculator, so 120 degree times 5, I have to add another more. It means I have to add another 600 degree. Okay, I have to add 600 degree, so 600 degree. Okay, if you look in the setting here and this Solidworks, this is revolution. So 660 degree is what revolution, since we know 360 degree is 1 revolution. So 600 divided by 360, so is 1.677, 1.666 revolution. That's why I paid it here, the value. This will be my revolution. Okay, the start angle will be where is normally by default I can go for 0 angle, so mean that it will start the spiral at that quadrant, but I need to be right setting. I go for 90 degree, so easy. I know that because this 90 degree angle will start at the base of my arm. I know my arm, my first arm that I have just created will be in the right position as my arm base point. So I go for 90 degree and I go for clockwise. If I go for counterclockwise, it will go this reverse spiral. So I go for clockwise. So this will be my curve. If you look here, this we have a curve in blue color. So this curve will be the guided curve for me to do curve driven pattern. Okay, before we do curve driven pattern, I need to, please take note on this, I need to isolate this arm, so that there is a reason why I isolate the arm from the shaft. Alright, okay, to do curve driven pattern, under here, if you click at the cursor here, we have under linear pattern here, we have curve driven pattern. I click at curve driven pattern. Okay, the first one setting on the left here is the direction. So this will be our spiral that I have just created. So this will be our guideline. So since, as I mentioned to you, that I need to make a pattern of 6 blades or 6 arms. So the number is 6 here. And I use here equal spacing. If I don't check equal spacing, it means it goes for distance. So because I already created a spiral of 65 millimeter height, so I make sure equal spacing, it means along this height, along this spiral length, it will divide the distance by 6. So it means that the arm will be equally distributed. So I will check at equal spacing. Also, take note, the setting is transform curve and also tangent to curve. And since I am doing curve driven for a body, I'm not using features, because since the arm is a separate body, I will not use features here. So I will click at the bodies, and the bodies here, I select this arm, and under here we have face normal. The face normal I have to select, because since this surface will be attached to the vertical shaft and also the spiral is positioned at the surface, so I will select this surface normal to be my base surface. So it means that we have a preview here. So it means that once the arm is rotated, it is duplicated 6 times. Since I put the number is 6, so I have total of 6 including the original one. And if you look the orientation of the arm, it facing to the face normal. So if I click OK, then we have 1, 2, 3, 4, 5, 6 of the arm. If I look from the top view, As I mentioned to you, the division of angle is 120 degree. So this is the way we do the modeling of the arm. So that's why we make the arm as a separate body. Let me exit isolate. So we have this 6 arm around this shaft. Alright. Okay, my next move, I will join these 6 arms to the shaft by using insert. Let me save first the file. Vertical shaft. Okay, my next move is under insert. I will combine everything. Make sure to use add. Select the shaft and select all the arm. Right. Then I click OK. So we have one body, the shaft and the arms as one solid body. Okay, the next thing to do, if we look at this sketch image, at the top of this shaft we have square holes 7 by 7 by the depth of 25, and before that, what I will do at this top surface, since at the top of the shaft we have kind of like a flat surface, to assist the procedure of mounting the vertical rod. If you look this internal gear here, internal gear, actually the orientation is like this, and this square rod will be mounted on top of this shaft, and we have a square holes to assist the works or procedure of assembly, and we need to maintain a line of that rod to the square holes here. We need some kind like features to assist us the works of assemble, so that easily to maintain the rod and the hole are in line. So what I will do, I make kind of like a curved surface here. Let me show you how I do that in front plane. So what I will do, I will create 3-point arch. One is touching the center line, another one is at this endpoint. Then I will create a center line from this point horizontal. Then I will make the relation tangent. Then I will close the loop to this point, to that point. Then I give a proper dimension of 1.5. Then I will do revolve cut. Make sure the axis of revolution is this line, and 360-degree cut. So I have kind of like a curved surface. So without this curved surface, when we do works like we assemble, we mount the square shaft, the square rod of that internal gear on top of the square holes, this kind of features of this curved surface kind of like assist us in terms of aligning and positioning the square rod to these square holes of this shaft. So then only I will do a square hole. So I will do a plane. My first reference is my top plane, and my second reference will be this point. So I have this plane, then I will create a sketch. I will do center rectangle, then I will give 7 by 7. Then I will do extruded cut by the distance of 25. Okay, another thing is that to assist us in terms of positioning the rod to the holes when doing assembly, I also need to add chamfer at these 4 edges. Let me give the distance. Let me try by 1. I think 1 is too big. Let me go for 0.5 to these 4 edges and also this circular edge. So this chamfer also kind of like helping the works of mounting the square rod to these square holes. Okay, the last thing to do at the bottom surface of the shaft, I create a sketch. Since if you look in this image, at the bottom of the shaft we have a diameter of 5 and the depth is 10. So I will do circle, diameter is 5. Instead of 5, I will do 7 for the diameter. So we have larger holes, and I will do extruded cut by the distance of 10. Then I have a diameter 10 holes. Okay, the idea is I'm not using 5 since this shaft will be mounted on top of the pole. Remember when I did part modeling of the container, at the base surface of the container we have a cylindrical shaft by diameter of 5. So we need a clearance, so I make the holes bigger. So we have a clearance of 1 millimeter. So it means that this shaft can easily rotate onto the shafts. Okay, I think that's about it for the... Okay, the last thing, I need to also chamfer these edges by distance of 1. Okay, the ideas of chamfering the edges is also these features will assist us the works of mounting the shaft to the vertical shaft of the container. Alright, I think that's about it for this vertical shaft. Let me save my file. Vertical shaft of my mini blender. I hope this video will assist you doing your vertical shaft of your mini blender. Okay, Alhamdulillah, I've completed this vertical shaft of my mini blender. Inshallah, in the next video I will show you how I do part modeling of... I think we have 2 more components left, which is the base plate of the pulley and also the coil spring. Okay, I'll see you soon in the next video. But before that, do not forget to click like and subscribe my channel. Assalamualaikum warahmatullahi wabarakatuh.